Hello everyone, good evening. This is lecture number 3 of ordinary differential equation. So if you haven't watched the previous two videos, go through that. This is the continuation of the previous class, right? So in order to have a continuation, to go through the previous two videos before watching this video, right? Okay. So far what we are doing in ODE is that we have been solving differential equations of first order and first degree, right? So we have been solving a differential equation of first order and first degree. I have listed out there are many methods to solve an equation of first order and first degree, right? So among that, we have completed variable separable method, right? We have completed variable separable method. Uh, Now in this class, we are going to start solving the problems based on equations reducible to the form in which variables are separated, right? So when you look at the question directly, it is not possible to separate the variable or it will be difficult, but it can be reduced, right? But it can be reduced in which variables are separated. How to reduce? That is what we are going to see now, right? So first you will I'll write on the procedure when the variables can be that is how the equation can be reduced. After that, which you can separate the variable, right? Okay, first I write on the theory part for one page. After that, we will start solving problem, right? Okay. Okay, so start now. Equation reducible to the form in which variables are separated, right? Okay. Equations reducible to the form in which the variables are separated. So equation of the form, so very easy. If you understand this theory part, the problem solving is very easy, right? So the equations of the form dy by dx, right? So dy by dx is equal to function of ax plus by plus c, right? So if you have a function of ax plus by plus c, in this pattern, right? Dy by dx equal to function of ax plus by plus c can be reduced, right? Can be reduced, can be reduced can be reduced to form reduced to the form in which the variables are separated, in which the variables are separated, right? Now you have to make one substitution, right? So whenever you see a question like dy by dx is equal to function of ax plus by plus c, it can be reduced to the form in which variables are separated, right? So what you have to do is you just put ax plus by plus c to be equal to some z, right? So if you have a function of ax plus by plus c, you just put ax plus by plus c to be equal to z. Now you differentiate with respect to x, right? Let's call this as equation number 1. Let's call this as equation number 1, right? So we have dy by dx equal to function of ax plus by. We call this as equation number 1. So put ax plus by plus c is equal to z. This is a procedure, right? If you understand this procedure, problem solving is very easy because you know how to solve by variable separable method, right? Now differentiate with respect to x, right? So that means this will be a, right? This will be b into dy by dx. This will be 0 is equal to dz by dx. right? dz by dx. Remember, z is a function of x, y, right? Okay. Now, therefore, we will have v into dy by dx is equal to dz by dx minus a, right? Let us take that a to be that side. So we have dy by dx, right? So we have dy by dx equal to 1 by b, right? 1 by b. So I'm just taking this b to this side into dz by dx minus a, right? So call this as equation number 2. Now what I'm going to do is I'm going to substitute this 2 in 1. That is, in place of dy by dx, I'm going to substitute this here. So put 2 in 1. Right? So from 1 we have dy by dx is equal to function of ax plus by plus c. So what I'm going to do is I'm just going to substitute dy by dx to be equal to 1 by b into dz by dx minus a, and this is f of z, right? Because we have substituted z to be equal to ax plus by plus c. Now this will be what? dz by dx minus a is equal to b into f of z. This implies dz by dx is equal to b into f of z plus a. So we have separated the variables, right? So we have dz by b into f of z plus a is equal to dx. Now we can see variables are separated, right? Because we have see here we have z and function dz and function of z, and here we have dx term. Variables are separated. Variables are separated. Integrate to get the required solution. Integrate and replace z is equal to ax plus by plus c to get the required solution. That's it. To get the required solution. This is how you have to do. This is the procedure. This is the procedure for solving, that is equation reducible to the form in which the variables are separated, right? So whenever you have function of ax plus by plus c, you just put this to be equal to ez, differentiate with respect to x. That is, you need to find dy by dx after using this substitution. Substitute back this dy by dx in equation in the given question, and then you have to separate z and dx to one side, right? So in this we have z and dz term one side, dx term other side, right? So we will do problem. It will be very easy for this. Is a procedure, right? This is a procedure. So whatever you have ax plus by plus c, you just substitute that to be equal to z, differentiate with respect to x, find dy by dx, and replace this dy by dx to be here, and then you separate the variables of z and dz to one side and dx to other side, right? So straight away we'll do problems, right? First problem, solve dy by dx, sorry, solve x plus y whole square dy by dx is equal to a square, right? So whenever you see a function of x plus y, ax plus by plus c, you just make use of what? Equation reducible to the form. So what I'm going to do is I'm going to put z to be equal to x plus y, right? Here a is 1, b is 1, c is 0. What I'm going to do is, it cannot be separated normally, right? But after using the substitution, we can separate. So put z to be, let's call this as equation number, right? So put z to be equal to x plus y. So differentiate with respect to x. Differentiate with respect to x, this will be dz by dx. And this will be 1 plus dy by dx, right? 1 plus dy by dx. So from that, you have to find dy by dx, right? dy by dx. This implies dy by dx is equal to dz by dx minus 1, right? Call this as equation number 2. Substitute this in 1, right? So put 2 in 1. Put 2 in 1. So what we have 1? So 1 is x plus y whole square dy by dx is equal to a square, right? This is equation number 1. So therefore, this becomes, this is z square. And what is dy by dx? It is dz by dx minus 1 is equal to a square, right? So this will be dz by dx minus 1 is equal to a square by z square by dx. We have dz by dx is equal to a square plus z square plus 1. We have dz by dx to be equal to z square plus a square by z square. This we will have dz divided by z square plus a square. That is, I'm separating dz and dx to one side. So we have z square dz is equal to dx, right? Now you can see I separated the variable, right? So functions of z and dz to one side, dx to other side. Now integrate. So integration of z square divided by z square plus a square dz is equal to integration of dx plus we'll add some constant c. Now remember, this is not a proper rational function, right? This is a rational function because functions of z, but it is not proper as both the degree of numerator and denominator are same, right? So what we have to do? We have to make use of division algorithm, right? So to perform this integral, let us call this as some star, right? Call this as some star. Now we need to perform z square divided by z square plus a square. So for that, so integration of z square divided by z square plus a square dz, right? This can be written as, so you have to make use of division algorithm. You have to divide z square by z square plus a square. It will be 1, so square plus a square, multiply by minus, this will be minus a square. That means z square can be written as z square plus a square into quotient plus remainder, right? That is, this is equal to this into this plus r. That means z square plus a square, quotient is 1, remainder is minus a square. Therefore, this z square can be written as z square plus a square minus a square divided by z square plus a square dz. Right? So what I'm going to do is I'm going to divide separately. This will be z square plus a square divided by z square plus a square dz, a square divided by z square plus a square dz, right? Just separating and dividing separately. So this will get cancelled. So integration of dz is z. And if I take this 1 by a square outside, 1 by z square plus a square is what? 1 by a tan inverse of z by a plus c. Right? So this 1a will get cancelled. So we have z minus a into tan inverse of z by a plus c. This is the integration value for this. So substitute in star. Right? Substitute in star. So this integration value is the required solution, right? Z square plus z square a square dz is equal to x plus some constant. So we have z minus a into tan inverse of z by a is equal to x plus c, right? So after that, you just replace z to be equal to x plus y. So we will have x plus y minus a into tan inverse of x plus y by a is equal to x plus c is the required solution. Right? So very simple. So whenever you see a function of ax plus by plus c, put that as z, differentiate with respect to z, find dy by dx from this substitution. Put this dy by dx value here, so that your function of z and dz will be one side and other dx will be that side, right? We'll move on to second problem. X minus y whole square, this x plus y whole square. So second problem will be solve x minus y whole square dy by dx is equal to a square, right? So instead of plus we have minus here. Call this as equation number 1. So what substitution we have to make? So put z is equal to x minus y. Differentiate with respect to x. So we will have dz by dx is equal to 1 minus dy by dx. So we will have dz by dx 1 minus dz by dx, right? So dy by dx will be, just bring this term that side. So 1 minus dz by dx, right? 1 minus dz by dx. So call this as 2. So put 2 in 1. So put 2 in 1. So 1 is x minus y whole square. Dy by dx is equal to a square. So what is x minus y? X minus y is z. So it will be z square. And what is dy by dx? 1 minus dz by dx is equal to a square, right? Okay. Good, yeah. Okay, so this will be, you have to do same as previous problem, right? It will be 1 minus dz by dx is equal to a square minus square, a square by z square. So this will be what? D 1 minus a square by z square. It's a very simple problem, right? So dz by dx. So we will have z square minus a square by z square is equal to dz by dx. Now separate z and dz to one side. So we will have z square dz, z square divided by z square minus a square dz is equal to dx, right? So integrate. So we integrate, we will have integration of this, integration of this. So again, you have to make use of division algorithm, right? So integration of z square divided by z square minus a square dz is equal to x plus c. Now we have to divide z square by z square minus a square. So this will be into 1 z square minus a square. So minus this will be plus will be a square. I can write z square as z square minus a square into quotient plus remainder, right? This will be z square minus a square plus a square divided by z square minus a square dz is equal to x plus c. Now divide this separately. This will be, we have dz. This will get cancelled. So this will be z. And the a square is common. A square is constant. So 1 by z square minus a square, right? So what is 1 by z square minus a square? Again, I have already listed out all the formula. It will be what? Integration of 1 divided by z square minus a square. So 1 by 2a log of z minus a by z plus a. Right? I have given you the formula in the first class itself. If you want, I can give you the formulas. This is the first class notes. So you can see 1 by, yes, 1 by a square. Yes, here we have 1 by x square minus a square. 1 by 2a log x minus a by x plus a plus c, right? So 1 by 2a log z minus a by z plus a is equal to x plus c is the required solution. So if you want, you can also replace, right? So replace z to be equal to x minus y will be x minus y plus a by 2 log x minus y minus a divided by x minus y plus a is equal to x plus c, right? The required. So if you want, you can also cancel this x, right? Not simplifying to further extent. So I think you understand how to do variable separate. I think you know, you have some idea, right? How when the variables can be reduced. After that, it can be separated. So whenever you have function of ax plus by plus c, put that to be equal to z. Differentiate with respect to x, you can easily do the problem, right? More. So we'll move on problem number 3. Is there any doubt up to now? So dy by dx is equal to 4x plus y plus 1 whole square, right? 4x plus 1. So call this as equation number 1. So put z is equal to 4x plus y plus 1. So whatever you have ax plus by plus c, put that to be equal to z. Differentiate with respect to x. I'll do fast because you know how to understand. You know how to do, right? So I'll do quickly. So dz by dx is equal to 4 plus dy by dx. This implies dy by dx is dz by dx minus 4, right? So call this as 2. So put 2 in 1. So put 2 in 1. So we have dy by dx is equal to 4x plus y plus 1 whole square. And what is dy by dx? It is dz by dx minus 4. And this is z square, right? Implies dz by dx is equal to z square plus 4. So dz by z square plus 2 square is equal to dx. Integrate this. Integration of dz divided by z square plus 2 square is equal to integration of dx plus c. So 1 by z square plus a square. So 1 by a tan inverse z by a, this x plus c, right? So 1 by 2 tan inverse of z by 2 is equal to x plus c. Now you replace z to be equal to 4x plus y plus 1. So 1 by 2 tan inverse of 4x plus y plus 1 by 2 is equal to x plus c is the required solution. Right? So by looking at the question itself, don't think that it is big, right? So just see ax plus by plus c pattern. So it can be reduced to the form in which variables are separated, right? Problem number 4. dy by dx equal to x plus y whole square. So call this as equation number 1. So put z is equal to x plus y. Differentiate with respect to x. So we will be having dz by dx is equal to 1 plus dy by dx. This implies dy by dx is equal to dz by dx minus 1. So call this as 2. So put 2 in 1. Right? So put 2 in 1. So what is dy by dx? Let's write the question first. Dy by dx is equal to x plus y whole square. Dy by dx is dz by dx minus 1. This is z square. So we have dz by dx is equal to z square plus 1. We have dz by z square plus 1 is equal to dx. Integrate. So integration of dz by z square plus 1 is equal to integration of dz. This is what? 1 by a tan inverse z by a equal to x plus c, right? Here a is 1 square. So tan inverse z, replace z to be equal to replace z to be equal to x plus y. So we have tan inverse of x plus y is equal to x plus c is the required solution. Right? On to problem number 5. In this class itself, we will be finishing this topic. Next class, we will be moving on to next method, which is homogeneous equations. Right? The problem number 5 is solve x plus y plus 1 into dy by dx is equal to 1. Right? So call this as 1. So whenever you see something like x plus y, ax plus by plus c, you need to what? Remember, put z is equal to this term, right? X plus y plus 1. So differentiate with respect to x. So we will be having dz by dx is equal to 1 plus dy by dx. So this implies dy by dx is equal to dz by dx minus 1. This is equation number 2. So put 2 in 1. So x plus y plus 1 dy by dx is equal to 1. This is z. Dy by dx is dz by dx minus 1 is equal to 1. So we have dz by dx minus equal to 1 by z, right? So this implies dz by dx is equal to 1 by z plus 1. We having dz by dx equal to z plus 1 by z. So separate z and dz to one side. So z into dz by z plus 1 is equal to dx. Integrate will be log. So this is not again a proper rational function, right? Because both the degrees are 1. Integrate this integration of z by z plus 1 dz is equal to integration of dx. So what we will do is we will divide z by z plus 1. So into 1 into 1. So we will have this as minus. So therefore I can write this z as z plus 1 into quotient plus remainder. So z plus 1 into quotient is 1, remainder is minus 1. I can write z as z plus 1 minus 1 divided by z plus 1 will be x plus c. Now divide this separately, right? So z plus 1 by z plus 1, 1 by z plus 1. Integration of z plus 1 by z plus 1 dz minus integration of 1 divided by z plus 1 dz equal to x plus c will be z will be log plus 1 equal to x plus c. Replace what is z? Z is x plus y plus 1, x plus y plus 1 minus log x plus y plus 1, 1 is equal to x plus c, right? This is a required solution. I can cancel this x also. Yeah, y plus 1 minus log x plus y plus 2 is equal to c is the required solution. Right, so I think you understand the core, right? Understand the core for this problem. So whenever you have, still no, okay. Move on to problem number 6. So x plus all x plus y plus 1 whole square dy by dx is equal to 1, right? Same problem, we have whole square here. So we'll do this, right? So call this as equation number 1. So put z is equal to x plus y plus 1. Differentiate with respect to x. So we will be having dz by dx is equal to 1 plus dy by dx. So we have dy by dx is equal to dz by dx minus 1. So put 2 in 1. So we have x plus y plus 1 whole square into dy by dx is equal to 1. This will be z square. And what about dy by dx? This dz by dx minus 1 is equal to 1, right? Okay, so we have dz by dx minus equal to 1 by z square. Take this 1 to that side. So we have dz by dx equal to 1 by z square plus 1. We have dz by dx is equal to z square plus 1 by z square, right? Separate the variable. So we have z square dz by z square plus 1 is equal to dx, right? You can see we are getting the same pattern, right? Function of z into dz, and we will always have dx here. Now integrate this. So integration of z square divided by z square plus 1 dz is equal to x plus some constant. Now again, both are, it is a rational function, but it is not proper because both the degrees are same, denominator, numerator. So we will divide this to 1, be minus 1, right? So I can write this z square as z square plus 1 into quotient plus remainder. So z square plus 1 into quotient is 1, remainder is minus 1. Therefore, this can be written as z square plus 1 minus 1 divided by z square plus 1 dz is equal to x plus c. Now, I'm going to write this as z square plus 1 by z square plus 1 z minus 1 divided by it. If you know how to do variable separable method, this is very easy. This is z. And what about 1 by z square plus a square? It is tan inverse of z by a, right? A is 1 here. So z minus tan inverse of z is equal to x plus c is a required solution. Replace, now what is z? Z is x plus y plus 1, right? So replace z to be equal to x plus y plus 1. So we will have minus x plus y plus 1 minus tan inverse of x to x plus c, the required solution. On problem number 7. Solve sin inverse of dy by dx is equal to x plus y. It solves sin inverse of dy by dx. This is nothing but dy by dx is equal to sin of x plus y. Bring this sign to that side. Call this as equation number 1. What you have to do? Put z is equal to x plus y. So put z is equal to x plus y. So therefore, what about to differentiate with respect to x? So we will have dz by dx is equal to 1 plus dy by dx. This implies dy by dx is dz by dx minus 1. So put 2 in 1. So put 2 in 1. So we have dy by dx is equal to sin x plus y. This is equation number 1. So what is dy by dx? It is dz by dx minus 1, right? dz by dx minus 1 is equal to sin z. So this will be dz by dx is equal to, take this to that side, we will have 1 plus sin z, right? So 1 plus sin z. So this will be dz by 1 plus sin z is equal to dx, right? So we have separated the variables and see z and function of z and dz one side, dx other side. So integration of 1 divided by 1 plus sin z dz is equal to x plus c. Now you have to integrate this. Right? Let's call this as star. Now how to integrate 1 divided by 1 plus sin z dz. So whenever you have like this, you just take conjugate. Just take conjugate. So 1 minus sin z divided by minus sin z. Right? I'm just going to multiply by conjugate dz. This will be integration of 1 minus sin z divided by 1 minus sin square z. Right? A plus b, a minus. So 1 minus sin square z is cos square z. So 1 minus sin z by cos square z dz, right? And again you divide this separately. 1 divided by cos square z minus sin z by cos square z dz. And 1 by cos square z is secant square z. Secant square z. And I can write this as cos z into cos z. So sin by cos is tan z. And 1 by cos is secant z. So this will be secant z tan z. Secant z tan z dz. Right? See, I'm just writing sin z by cos square z as sin z by cos z to 1 by cos z. This is tan z, this is secant z. Now integrate this. So integration of secant square z is tan z. Integration of secant z tan z is what? Secant z. Very standard problem, right? Tan z is, you just think of differentiation. Which function differentiates to give secant square z? It is tan z. Which function differentiates to get secant z tan z? It is secant z, right? This is the integral value of 1 divided by 1 plus sin z. Substitute in star. What is star? Integration of 1 divided by 1 plus sin z dz is equal to plus c. So this value is tan z minus secant z. Tan z minus secant z x plus c. Now replace what is z? Z is x plus y. So replace z to be x plus y. So tan of x plus y minus secant of x plus y is equal to x plus c is the required solution. On to problem number 8. Solve dy by dx is equal to cos x plus y. For that we will do sin x plus y cos x. Right, so in the previous problem we have only sin x plus y. Here we have sin x plus y plus cos x plus y. Right? Call this as equation number 1. Put z to be equal to x plus y. Difference. Remember why I am putting, because here we have x plus y, right? That is why only doing. Differentiate with respect to x. So we have dz by dx is equal to 1 plus dy by dx plus dy by dx is equal to dz by dx minus 8. Put 2 in 1. Put 2 in 1. We have dy by dx is equal to sine of x plus y plus cos of x plus y. Dy by dx is dz by dx minus 1 is equal to sin z plus cos z. Implies dz by dx is equal to sin z plus cos z plus 1, right? The previous class itself I have given you the formula, right? So sin 2 theta is 2 sin theta cos theta. That means sin theta be 2 times sin theta by 2 cos theta by 2. And we know 1 plus cos theta is 2 cos square theta by 2. Right? I'm going to make use of this again. I'm going to write this sin z as 2 times sin z by 2 cos z by 2, and 1 plus cos z as 2 times cos square z by 2. Right? Now what you can do is can take what we will have is we have this to be equal to 2 cos square z by 2. Okay, no. Let us separate the variables here. So we have dz by dx, right? So we have dz divided by, so we take this 2 outside. We have sin z by 2 cos z by 2 plus cos square z by 2 is equal to dx, right? What I'm going to do is I'm going to divide the divide numerator and denominator by cos square z by 2, right? I'm going to divide this by cos square z by 2. So if I do this, you can see what happens, right? This will be, I'm going to divide by cos square z by 2, divide by cos square z by 2, divide by cos square z by 2. This term will be 1 and 1 cos will get cancelled. So we will be left with dz, right? dz and 1 by cos square z is secant square z by 2 divided by, we will have secant square z by 2 dz in the numerator, and here we have 2 into sin z by cos z, right? I'm dividing. So sin z by 2 cos z by 2. Sin z by 2 cos z by 2 will be tan z by 2 and this will be 1. So 1 plus tan z by 2 is equal to dx. Now this I can write this as, let's take this 2 to that side. So 1 by 2 secant square z by 2 divided by 1 plus tan z by 2 is equal to dx. Now you can see f of x, f dash of x, right? If I differentiate this, what do you have? 0 tan z by 2 is secant square z by 2 into 1 by 2. This is what? Log of 1 plus tan z by 2 will be x plus c. Right? So 1 log of 1 plus tan z by 2. Now replace z to be equal to, what is z? X plus y. So we have log of 1 plus tan x plus y by 2 is equal to x plus c. Is the required solution. So very important formula, we know integration of dash of x by f of x dx is log f of x. Right? We'll move on to ninth problem. So dy by dx is equal to dy by dx is equal to 2 divided by x plus 2y minus 3. Call this as equation number 1. So put z is equal to x plus 2y minus 3. So differentiate with respect to x. So we have dz by dx is equal to 1 plus 2 into dy by dx. So we have dz by dx minus 1 is equal to 2 into dy by dx. We have 1 by 2 dz by dx minus 1 is equal to dy by dx, right? Call this as equation number 2. So put 2 in 1. So put 2 in 1. So we have 1 by 2 dz by dx minus 1 is equal to 2 by z, right? Let's take this 2 to that side. We have dz by dx minus 1 is equal to 4 by z. This implies dz by dx is equal to 1 plus 4 by z. We have dz by dx is equal to z plus 4 by z. So z into dz by z plus 4 is equal to dx. Again, it is not a proper rational fraction, right? So we will divide z by z plus 4. So 1 plus 4 will be minus 4, right? So I can write z as z plus 4 into quotient plus remainder. So this minus 4. So we integrate this, will be integration of z plus 4 minus 4 divided by z plus 4 dz will be integration of dx. So I can write this as integration of z plus 4 by z plus 4 dz minus 4 divided by z plus 4 dz is equal to integration of dx plus c. This z, this 4 times 1 by z plus 4 is log z plus 4, right? F of x, f dash of x is equal to x plus c. Now replace what is z? Z is x plus 2y minus 3. So x plus 2y minus 3 minus 4 times z minus 4 times log of x plus 2y minus 3 plus 4 is equal to x plus c. So this x will get cancelled. So we have 2y minus 3 minus 4 times log of x plus 2y, 4 minus 3 is plus 1 is equal to c is the required solution. Right, so if you want, you can also take this 2 outside, right? You can do anything, but doesn't matter, right? Is there any doubt up to now? On problem number 10. Solve dy by dx cos x plus y. Right? Here we have sin x plus y. Problem number 7. Eighth problem is sin x plus y cos x plus y. Now this is cos x plus y. So call this as equation number 1. So put z is equal to x plus y. To differentiate with respect to x. So we have dz by dx is equal to 1 plus dy by dx. This implies dy by dx is equal to dz by dx minus 1. So put 2 in 1. So if we put 2 in 1, we have dy by dx is equal to cos of x plus y. Dy by dx is dz by dx minus 1 is equal to cos z. So we have dz by dx to be equal to 1 plus cos z. And we know 1 plus cos z is secant 2 cos square z by 2. And let us bring this 2 cos square z by 2 here will be dx. And what about 1 by cos square z by 2? It is 1 by 2 secant square z by 2 dz is equal to dx. Now integrate. Integration of 1 by 2 secant square z by 2 dz is equal to x plus c. Let's keep this 1 by 2 as it is. What is secant square z by 2? It is tan z by 2 into 1 by 2, right? So, sorry, tan z by 2 divided by 1 by 2, right? Because we are integrating. tan z by 2 divided by 1 by 2, right? Very simple, right? Integration of secant square. What is integration of secant square f of x? Is tan f of x divided by f dash of x. I've written you all the formulas, right? 1 by 2 is equal to x plus c. This 1 by 2 will get cancelled. So tan z by 2 is equal to x plus c is the required solution. So replace z to be equal to x plus y. So we have tan z by 2 is equal to x plus c. So tan of x plus y by 2 is equal to x plus c, the required solution, right? On to 11th problem. Solve the solve. Still we have only 4 more problems, right? We finish off in another 10 to 15 minutes. So solve x plus y dy is equal to dx, right? So what I'm going to for this problem is I'm going to do slightly different, right? So if you have dy by dx, we will have 1 by cos x plus y. But we already know, it is easy to evaluate cos x plus y rather than 1 by cos x plus y. So what I'm going to do is I'm just going to write this as dx by dy is equal to cos x plus y. Right? So instead of writing dy by dx, I'm writing dx by dy is equal to cos x plus y. If you are writing dy by dx, you will have 1 by cos x plus y, which will take some more time to integrate. Right? Then this. Now we will do this as usual. Put so okay, I write this in red color. Cos x plus y dy. Cos plus y dy is equal. Right? So I'm writing dx by dy. Okay. So put x plus y. Put z is equal to x plus y. Now instead of differentiating with respect to x, I'm going to differentiate with respect to y. Then only we will have dx by dy, right? This will be dz by dy. This will be dx by dy, and this will be 1. You understand the difference, right? We need dx by dy. Usually we will have dy by dx in the previous problems. Just for simplicity, I'm just writing this as dx by dy, and I'm differentiating with respect to y. Then only you will have dx by dy, right? This implies dx by dy to be equal to dz by dy minus 1. So call this as 2. So put 2 in 1. So put 2 in 1. So we will have dx by dy to be equal to cos x plus 5. What is dx by dy? This dz by dy minus 1 is equal to cos z. dz by dy is equal to 1 plus cos z. So 1 plus cos z is what? Same, right? dz by dy to be equal to, so 1 plus cos z. So 1 plus cos z is 2 times cos square z by 2. So this will be dz divided by 2 times 1 plus cos square z by 2 is equal to dy. This will be 1 by 2 secant square z by 2 dz equal to dy. Now integrate. So 1 by 2 integration of secant square z by 2 dz equal to integration of dy will be 1 by 2 tan z by 2 divided by 1 by 2 equal to y plus c. This 2 will get cancelled. Tan z by 2 is equal to y plus c is the required solution. Right? In the previous problem, we have tan z by 2 is equal to x plus c. Right? Remember this dy by dx is equal to cos x plus y. This is dx by dy is equal to cos x plus y. Right? So replace z to be equal to plus y. So tan x plus y by 2 is equal to y plus c. Right? On to problem number 12. So solve dy by dx equal to 1 divided by x minus y plus. Solve this as equation number 1. So by looking at the question itself, don't take LCM and then you don't complicate, right? So put z is equal to x minus y, differentiate with respect to x, right? So dz dx is equal to 1 minus dy by dx. This implies dy by dx is equal to 1 minus dz by dx. So put 2 in 1. So we have dy by dx is equal to 1 divided by x minus y plus 1. So dy by dx is 1 minus dz by dx is equal to 1 by z plus 1. Now take this 1 to that side. So we will have, can cancel this one, right? So you can cancel this one. So we will have minus dz by dx is equal to 1 by z. So we will have minus dz is equal to dx. So integrate will be minus z square by 2 is equal to x plus c, right? Minus z square by 2 is equal to x plus c. Now replace z to be equal to x minus y, right? So minus of x minus y whole square by 2 is equal to x plus c is the required solution. If you want, you can simplify this more extent, right? So you want and simplify more. Then move on to problem number 13. Solve dy by dx solve dy by dx equal to x plus y plus 1 divided by x plus y. Solve this as equation number 1. So put z is equal to x plus y. And don't put x plus y plus 1. X plus y is common in both, right? So differentiate with respect to x. So we have dz by dx is equal to 1 plus dy by dx implies dy by dx is equal to dz by dx minus 1. All this as 2. So put 2 in 1. So we have dy by dx is equal to x plus y plus 1 divided by x plus y. So dy by dx is dz by dx minus 1. This will be z plus 1 by z, right? So we have dz by dx is equal to z plus 1 by z minus 1. We have dz by dx is equal to, will get cancelled. So we will have only 1 by z, right? Plus 1. Okay, sorry. Plus 1. This will be z plus 1. So we will have dz by dx is equal to 2z, right? 2z plus 1 by z. That means we will have z dz divided by 2z plus 1 is equal to dx. Now integrate. Again, this is not a proper rational function because both the degrees are same. So z divided by 2z plus 1 dz is equal to integration of z. We have to divide z by 2z plus 1. Z by 2z plus 1. So 2z into something is what? 2z into something has to be z, right? So this has to be what? By 2, right? Just divide by 1 by 2. So this will be z plus 1 by 2, right? Z into will be minus, this will be minus 1 by 2. So this z can be written as 2z plus 1 into quotient plus remainder 2z plus 1 into by 2 minus 1 by 2, right? And take this 1 by 2 outside and write this as 2z plus 1 minus, right? 1 by 2, take this 1 by 2 outside. As it is. This will be integration of 2z plus 1 to 1 by 2 minus 1 by 2 divided by 2z plus 1 dz will be x plus c. Divide this separately. So we have 1 by 2 integration of 2z plus 1 by 2z plus 1 z minus 1 by 2 1 divided by 2z plus 1 z is equal to x plus c. Will be 1 by 2 into z, and here you can see 2 is missing, right? Because if we differentiate, we will have 2. What we'll do is we'll multiply and divide by 2. So this will be z by 2 minus 1 by 4 by 2 minus 1 by 2, 1 by 2 is 1 by 4. Will be log 2z plus 1 is equal to x plus c, right? This is the required solution. So replace z is equal to, so what is z? Z is x plus y. So x plus y by 2 minus 1 by 4 log 2 into plus y plus 1 is equal to x plus c, the required solution. Okay, so move on to problem number 14. Solve x plus 2y plus 2y into dx minus y is equal to dx plus dy. X plus 2y dx minus y. So what we'll do is we will separate dx and dy first. So we just multiply this dx here. So we will have x plus 2y dx plus 2y dx minus x plus 2y dy is equal to dx plus dy. Now if I take dx common, we will have x plus 2y will have x plus 2y. Here we will have minus 1, right? Here if I take dy common, here we will have 1. You take this term to that side. So that means 1 plus x plus 2y. That means we will have dy by dx is equal to x plus y minus 1 divided by x plus 2y plus 1. This is the required question now. Now put z is equal to x plus 2y, right? We'll put z is equal to x plus 2y. So differentiate with respect to x. We will have dz by dx is equal to 1 plus 2 into dy by dx. So we will have dz by dx minus 1 is equal to 2 into dy by dx. So dy by dx is equal to 1 by 2 dz by dx minus. So put 2 in 1. So dy by dx is by 2 dz by dx minus 1 will be z minus 1 by z plus 1, right? Minus 1 by plus 1. So from now on, I think you can do, right? We'll have dz by dx minus 1 is equal to z minus 1 divided by dz will be 2z plus 2, right? If I divide this by 2, will be dz by dx is equal to z minus 1 by 2z plus 2 plus 1. So we will have dz by dx equal to z minus 1 plus 2z plus 2 divided by 2z plus 2. So this will be sorry, this will be 2z minus, sorry, to bring this, I can take this to that side, right? Will be, to bring this 2 to this, last multiply this, we will have 2z minus 2 by z plus 1, 2z minus 2 by z plus 1, 2z minus 2, 2z 2 plus z plus 1 divided by z plus 1 will be dz minus 1 divided by z plus 1, right? So we will have z plus 1 by 3z minus 1 dz equal to dx. To integrate, again this is not a proper rational function, so we will divide z plus 1 by dz minus 1 will be 1 by 3 will be z minus 1 by 3 multiply by minus, this will be 1 minus 1 by 3. This 2 by 3, right? 2 by 3. That means z plus 1 can be written as dz minus 1 into quotient plus remainder. So b minus plus, right? 4 by 3. So this will be 3z minus 1 into quotient plus remainder, right? So very simple, right? You just have to multiply 3z minus 1 into 1 by 3, which will be z minus 1 by 3. So multiply throughout by minus. So this will be minus, this will be plus. So 1 plus 1 by 3 is 4 by 3. Therefore, if I integrate, I can write z plus 1 as 1 by 3 into 3z minus 1 plus 4 by 3 whole divided by 3z minus 3z is equal to x plus c. So divide this separately. So we will have 1 by 3 dz 4 by 3 integration of 1 divided by 3z minus z is equal to x plus c. This will be z by 3. So 4 by 3. So just multiplying and dividing by 3. Integration of 1 divided by 3z minus 1 equal to x plus c. So this will be z by 3 plus 4 by 12, 4 by 9 log of 3z minus 1, right? F of x, f dash of z, f dash of z equal to x plus c. So replace Z to be equal to, what is Z? X plus 2y, the required solution. Any doubt up to now? Is any doubt up to now? Yes, we're going to wind up, only one more problem left. Last problem, which is problem number 15. Solve x plus y minus a divided by x plus y minus b into dy by dx is equal to x plus y plus a divided by x plus y plus b, right? So call this as equation number 1. So put z is equal to x plus y. So differentiate with respect to x. So we will have dz by dx is equal to 1 plus dy by dx. This implies dy by dx is dz by dx minus 1. So put 2 in 1. So if we put 2 in 1, we will have what? Z minus a divided by z minus b into dy by dx, which is dz by dx minus 1 is equal to z plus a by z plus b, right? So that means we will have dz by dx minus 1 to cross multiply this z plus a into z minus b divided by z minus a into z plus b. Take this 1 to that side. We'll have dz by dx is equal to z plus a z minus b divided by z minus a z plus b plus 1, right? Minus a z plus b plus 1. So cross multiply this dz by dx to be equal to now z minus a z minus b plus z minus a z b z minus 2 z plus b divided by z minus a to z plus b. So what we can do is you just have to multiply inside. So dz by dx is equal to, so z square minus bz z square minus bz plus az minus ab, right? Plus az minus b z square plus bz z square plus bz minus az minus a divided by, so here we have z square plus bz, here we have minus az minus ab minus bz plus bz plus az minus z will get cancelled. So we will have 2 times z square minus ab divided by z square. So if I take z common, we will have b minus a into z minus ab, right? So here we have dz by dx. Now separate variables as already separated. So we have z square plus b minus a into z ab divided by z square minus ab is equal to 2 dx, right? Integrate this. So integration of z square plus b minus a z ab divided by z square minus ab is equal to 2 times integration of dx, right? Again, you can see this is not a proper rational function. Both the degrees are same. So we will do division algorithm. So we have z square plus b minus a into z minus ab divided by z square minus ab to 1. So z square into 1 is z square. Here we have minus ab will be minus, this will be plus. So this will be b minus a into z. This two will get cancelled, right? Plus ab minus ab. This also will get cancelled. So that means this can be written as z square minus ab. That means this can be written as integration of z square ab to quotient plus remainder divided by z square minus ab equal to 2x plus c. So z square minus ab into quotient is 1. Remainder is b minus a into z divided by z square minus ab dz is equal to 2x plus c. It's this quotient, this remainder. Now divide this separately. So we will have integration of z square minus ab by z square minus ab dz, and this will be b minus a is constant, integration of z divided by z square minus ab be 2x plus c. Now we can see f of z, f dash of z. So 2 is missing, will be z. What I'm going to do is I'm going to divide by 2, multiply by 2. So z plus b minus a by 2 log of z square minus ab is equal to 2x plus c. Right? This is a required solution. If you want, you can replace z to be equal to z to be equal to what is z? X plus y, right? Plus y. So this will be x plus y plus b minus a by 2 log x plus y whole square minus ab is equal to 2x plus c is the required solution. So if you want, you can also bring this x to one side. You can cancel this 2x minus x to be equal to x. It is the required solution. Or b minus a by 2 log x plus y whole square minus ab is equal to 2x minus x is x minus y plus. Right, I'm just taking these two terms to that side. Right, that's it. So we have completed the second part, which is even though the variables are not separated, we can make use of the substitution so that the variables are separated. So we have did 15 problems, right? So I think you can do any problem from now on. So whenever you see a function of ax plus by plus c, you just have to think of what? Reducing equation reducible to the form in which the variables are separated, right? So the next class we'll be starting solving the next type of method, which is homogeneous equations, right? So if you have any doubt, you can ask, or else we'll wind up. No doubt, right? Okay, thank you. So I'll send the PDF in the Telegram group, right? Okay.